My little part will contain some about urban measurements, and I will will share you the examples of the low-cost measurement, especially in the Arctic cities. But for beginning, I would like to note that there exists a very interesting and useful document from WMO, from the World Meteorological Organization, that consists the guidance to representative meteorological observation at urban sites. So now it's a kind of the Bible for all urban meteorologists that have an idea to get good results from the urban weather station. And there is a very good recommendation how to establish your urban site for getting good results. So I also share for you this link. So it's full and very wide document, but I think everyone could find something useful, especially for himself. So, but sometimes, especially in the Arctic cities, it exists there's some problems with a WMO station, that if the station isn't situated in the city borders. So here an example of the one of the of the biggest cities of the Arctic region. So it's Kola Peninsula, the Russian Federation, the traditional mining region. So it's a city of Apatite, and it is situated on the hill, but you see the WMO station is situated near the lake. And of course, due to some microclimatic features, so we cannot get some data from the WMO station. So it's the meteorological of the natural landscape. That's why, so then we organized the first microclimatic experiment. So we used the different things of measuring. So the standard stationary automatic weather station, the mobile weather station that it's used by car. So when you organize your weather station on the car, and you are trying for to moving and measuring some microclimatic features. Of course, it's not good, for example, for PM, because the car is also the source of PMs. But for traditional meteorology, if you can maintain the constant small speed of car movement, so it works. For example, in some movement, so for getting good results, you can also to join the automatical weather station with the low-cost sensors, that you can organize the real meteorological network. And the agreement between different parts or different kinds of measurements should be good. And in this case, you can keep in mind that your idea to organize some urban meteorological network will be successful. So, for example, so Michael already showed these results of urban heat island research in small cities. So it's the red. It's an automatic weather station with the low-cost sensors, but also sometimes you can organize some investigation of the ground level thermal inversions if you need it, because if you don't have the funding for the traditional air quality networks, you know that air quality, the gas analyzers are not so cheap, and I'd say that it's quite expensive. But if you have an interest about the air quality, so you can begin from the inversion monitoring. So in this case, you need to levels of measurement of the temperature, and if you have the statistics of the inversion, you can have the idea about how the meteorology and the synoptical conditions are forming. So it's kind of the intensive campaign. So they are using automatic weather station in the right and the drones that Mikkel already showed us, these wonderful pictures, but also the small scale sensors and the cheap sensors, the eye buttons and hobby temperature loggers. So it's about no more than 50 or 100 euros per unit. So, and also, if you have the possibility to use a microwave profiler, so in this case, so normally you can get the urban meteorology not only in surface layer. So it's very important, especially in the Arctic latitude, especially in Finland, in Iceland, in the northern Norway that Michael already showed us. And because according to this, you can understand what the nature of the different inversions. So you can see on this photo, you see the two different inversions. So every inversion is closely connected with the urban air quality. So, and in this case, you can add to this kind of sensors also the purple air sensors. It's a traditional network for small scale and relatively low cost PM2.5 and PM10 sensors. So, and we organized such first network in Siberia. So for this network contains only two sensors, but one is in the urban core and the second one is in the airport. And this summer, so it was only two purple air sensor that's registered the smoke from the forest fires in Siberia and in the Yakutia. So the first results show that exists some difference between urban core and the natural core, but I think what I would like to conclude our small lecture that if you have the very clear idea what do you need to measure, now you can find the ways for organizing urban scale measurements for each funding. You can begin by the low-cost sensors, and after you can go to the most powerful networks. But anyway, you firstly should have the clear idea. So what do you need to measure? What result or which phenomenon you would like to investigate? And I think if this idea is clear, I think you will be successful on your investigation. That's why me and Michael, so would like to